Hello everyone, my name is Diksha and I am from the Bodhi Academy. Today I am going to continue with group 18 elements from P block chapter of standard 12 chemistry. So let us continue with the group 18 elements, and with this we will finish the chapter P block elements. Okay. So group 18 elements are noble gases, which is the last group of P block. Okay, so group 18, it consists of noble gases. So noble gases consist helium, neon, argon, krypton, xenon, radon and organoson. Now occurrence, they occur in the atmosphere except radon and organoson, and in dry air their abundance is around 1%, of which argon is the major constituent. Then radon is obtained by the decay product of 226 radon. So here we can see this is the decay product. Then about organoson, it is synthetically by the collision of CF atoms with calcium ions. Then about organoson we will not study much in this, but we will study up to the radon. So helium, neon, argon, krypton, xenon and radon. Now their electronic configuration is fully filled, that is NH2NP6 is their electronic configuration, and helium is only having 1s2, which is not which does not follow this configuration. Then ionization enthalpy, they are having very high ionization enthalpy because of the stable orbital or stable electronic configuration. Then their atomic radii increases down the group. Similar trend is followed here like other elements. Atomic radii increases down the group. Then electron gain enthalpy, they do not have tendency to accept more electrons because they are already filled. So they have large positive values for electron gain enthalpy. Then talking about their physical properties, they are monoatomic. They are colorless, odorless and tasteless. Also they have very low melting boiling points, and helium is having the lowest boiling point. Then talking about their chemical properties, the noble gases except helium have completely filled NH2NP6 electronic configuration. So helium is the exception over here since the size of helium is small. So NH2NP6. They have very high ionization enthalpy and more positive electron gain enthalpy. Then we will talk about xenon fluorine compounds. Now most of the noble gases, they cannot form compounds or they do not combine with any other element to form the compound, and the reason behind this is because of their small size and their stable field configuration or fully filled configuration. But xenon can form compounds because of the size, because of its size. Okay, so xenon, when it is treated with fluorine in excess, it gives xenon difluoride. When you treat it with 2 fluorine molecule, then it gives xenon tetrafluoride, and when 3 fluorine molecule, it gives xenon hexafluoride. So this is the way to prepare xenon compounds. Then xenon hexafluoride can be also prepared by interaction of xenon tetrafluoride and dioxygen difluoride. So this is the reaction showing the preparation. Then xenon difluoride, tetrafluoride and hexafluoride, they are colorless crystalline solids and they sublime readily at 298 Kelvin, and they are powerful fluorinating agents. Then the structures of 3 xenon fluorides can be deduced from the VSEPR theory, valence shell electron pair repulsion theory. So they have given the structures over here. We can see this is XeF2, okay, xenon difluoride. Then this is XeF4, this is xenon tetrafluoride. The shape or geometry of the XeF2 is linear and this geometry is square planar. Then XeF6 is distorted to octahedral, XeOF4 is square pyramidal and XeO3 is pyramidal. These shapes and their names are very important in terms of exam because they ask the shapes or the names of this. Then one more important thing over here is these reactions. So xenon oxygen compounds. So xenon compounds can undergo complete hydrolysis and partial hydrolysis. So when they undergo hydrolysis, now this is called as complete hydrolysis. So complete hydrolysis of xenon tetrafluoride and xenon hexafluoride with water to give xenon trioxide. So xenon tetrafluoride, when treated with water molecule, it gives xenon plus xenon oxide and hydrogen fluoride, and when it is treated with 3 molecules of water, it gives xenon oxide and hydrogen fluoride. So these two reactions tells us about the complete hydrolysis of xenon tetrafluoride and xenon hexafluoride. Then partial hydrolysis of xenon hexafluoride gives oxyfluorides, that is XeOF4 and XeO2F2. So this is the partial hydrolysis which is carried out by the xenon hexafluoride. So xenon hexafluoride, when treated with water, it gives xenon oxyfluoride. This is oxyfluoride, and this is another type of oxyfluoride, that is when it is treated with 2 molecules of water. So these two reactions are very important in this part, that is group 18 elements, as it is asked frequently in the question paper. Then the structures equally they are important. Here you can see there are 3 lone pairs on xenon. Okay, so repulsion will be more in this case, but here there are only 2 lone pairs. Okay, so there is having square planar structure, and in this case it is only 1 lone pair, and in this 2 case also one lone pair is given. Then xenon oxide is a colorless explosive solid, has pyramidal molecular structure, and xenon oxyfluoride is a colorless volatile solid liquid and has a square pyramidal structure, which is given already in this. Okay, so only these questions can come in this group 18 parts, because there is no much information given on group 18, as they do not react easily with any other element. So P block elements is about 4 groups, that is group 15, 16, 17 and 18, and group 15 and 16 you can see that in 15 and 16, since there are important elements present in that, we have more about group 15 and 16 in this chapter, and about 17 and 18 is less as compared to those 2 groups. So what important things you have to remember here is, first of all, their electronic configuration, all groups electronic configuration, then all the trends in all the 4 groups, ionization enthalpy, then electron gain enthalpy, electronegativity, atomic ionic radii. So all these trends are equally important in all the chapters. Along with that, anomalous behaviors of those particular elements in first 3 groups, 15, 16 and 17. Okay, you need to study the anomalous behavior of first elements in all the groups, and along with that all the reactions, then compounds and their behavior, then hydrides reactivity. So all these are important, along with the structures, okay, and reactions. So this is about P block elements chapter. With this I finished with the P block elements. So I will start with the new chapter in the next video. Thank you.